Okay, let's try another system of equations where we have to use the addition method. Let's do the system 2x equals 7y minus 17 and 5y minus 17 minus 3x. I'm sorry, that should be 5y equals 17 minus 3x. Okay, so again, it's a system of equations, two equations with two variables, and we want to try and solve this. So one thing that you should notice, this is very important, this is why I'm doing this specific example, this is not set up in the normal way. What we want to try and do is get all of our x's and y's to one side, line those up vertically, and then get all the constants, or the things that don't have x and y, to the other side of the equation and line that up vertically. So the first thing I can see is that top equation there needs to be rewritten. I need to bring that 7y over to the left. So we're going to subtract 7y on the left-hand side, on both sides of that first equation. So we're going to get 2x minus 7y equals negative 17. Don't lose that negative sign out in front of the 17. And the second equation, the x needs to come to the left-hand side, so that negative 3x, we're going to add 3x to both sides. And again, I'm going to line it up vertically so that 3x is here. I still got my plus 5y, and then that's going to equal 17. Okay, so now I'm going to look at these things, now that it's set up in the correct way, and say, okay, is this going to be an easy thing to use substitution? Probably not. I don't have any coefficients of 1, and I think the elimination method by addition is going to work out the easiest. I don't have any of my coefficients the same. We need to, we need to make them the same somehow. I can certainly look at the 2 and the 3, or I can look at the 5 and the negative 7. The 5 and the negative 7 would work nicely because one of them is already negative, the other one is positive. I would have to multiply each equation by something, however, in order to make those the same. And the same thing is going to go with the 2 and the 3. It depends on how big of numbers you want to start to make these things as to which one you want to use. I would prefer to keep the numbers smaller, so I'm going to use the 2 and the 3. Now the idea is, what do I multiply times 2 and what do I multiply times 3 to make those the same? What you're really looking for basically is a least common denominator. There's no fraction here, but that's the general idea. So the least common denominator between these two things would be 6. So I would have to multiply the top equation 2 by a 3. Let's multiply that whole thing by 3. I'm going to have to multiply the bottom one by 2 to make the x is 6, but I want to multiply it by a negative 2. That way, I can make it a negative 6 on the bottom, and then we're ready to use the addition method. So again, the biggest thing is make sure you multiply every single piece that you've put in that parentheses there by the number on the outside. You can't leave off one of them. So on the top one, 3 times 2x is 6x. 3 times negative 7y is negative 21y, equals, and then don't forget the right side, 3 times negative 17 is negative 51. Okay, and in the bottom equation, now we're going to multiply everything through by a negative 2. So negative 2 times 3x is negative 6x. That's good, that's what we wanted. Negative 2 times the 5y is negative 10y. And then negative 2 times 17 is going to be negative 34. Now we are ready to add these things down. If I was to add the 6x and the negative 6x, perfect, that goes away. The negative 21y and the negative 10y is going to give us negative 31y. And then negative 51 and negative 34 is going to add up to negative 85? Negative 85, I believe, is the answer to that one. If I did that correctly. I think so. This is not going to be a very pretty answer, because now if I have to divide both sides by negative 31, I get negative 85 over negative 31. Well, first of all, a negative divided by a negative is positive, but 85 and 31 do not simplify very nicely. Okay, that doesn't work out very well. What we have done in the past is we've taken that 85 over 31 and we've plugged it back into one of the original equations for y. That's going to be really difficult to solve. Not to say it can't be done, but it is going to be difficult to solve. So instead of doing that, I'm going to actually go back to these equations right here. So I'm going to go back to these two equations right here, and now I'm going to change what I did before. Instead of using the x's, now I'm actually going to use the y's, and I'm going to redo the process. So what would I have to multiply that top equation by? Well, first of all, between 7 and 5, the common denominator there is 35. That's the smallest number they both go into. So I'm going to have to multiply that top one here by 5. So on the right-hand side in red, I'm going to multiply it by 5. And the bottom one I'm going to have to multiply by 7 in order to get those 35s. So right below this one here, I'm going to remember, don't forget to distribute to everything. So 5 times 2x is 10x. 5 times negative 7 is going to be negative 35y. And then 5 times negative 17, let's see, 5 times negative 17, I believe is negative 75. If I did that correctly, let me think about that. Yeah, that's right, negative 75. Okay, do the same thing with the bottom. 7 times the 3x is 21x. 7 times the 5y is plus 35y. That's the part we needed to match, which is good. And then 7 times 17, let's see, I'm trying to do this in my head. 7 times 17 is going to be, I think it's 119. I hope I'm doing this correct. I'll know at the end. Now I can add these two things up and we're going to see what we get. So if I add the x's, I'm going to get 31x. If I add the y's, those go away. Perfect. And then 119 and negative 75 added together is going to be, oh geez, what is that? 44, I believe. I think that's correct. 44. Did I do that correctly, or is that wrong? Nope, I know what's wrong. It's not this. I was wrong in the multiplication here. That's not 75. That should be negative 85. Oops. Negative 85. Right, that's correct. Negative 85, which actually makes this 34. Yes, that is correct. So now if I divide both sides by 31, I would get 34 over 31. And don't worry about this. I'm trying to do all this in my head. You guys will have your calculators. The biggest thing is please leave these as fractions. Do not give me decimals, because these decimals are not going to be exact answers. These fractions are exact answers. The decimals are only going to be approximated. You would have to round something. Your calculator cannot give you the exact answer to these. So please leave those as fractions in your answer. So the actual ordered pair would be 34 over 31, comma 85 over 31. Not a very pretty answer. That's not one of those that works out nicely just to be like, 2 negative 10 or something like that. But that is the place of intersection of those two systems of equations. Alright, so now we've done a few of these equations. All of them have had solutions. As a matter of fact, all of them have had one solution. So all of those have been ones where the lines have intersected one time. But I did say that there was two other possibilities. Let's take a look at what those would look like. The first one we're going to deal with here is actually one of these that's going to have no solution. So the first equation is 4x plus 6y equals 12. And the second equation is 6x plus 9y equals 12. Okay. So in order to solve this one, well, I guess you could use either method here. You could use substitution, or you could use the addition method. I think we're going to go with the addition method, just because I still think it's easier in this case. If I want to eliminate one of these things, I'm going to look at the 4 and the 6 out in front of the x. So we're going to multiply the top one. Now, keep in mind, you can multiply 4 times 6 to get a common denominator of 24. There's actually a smaller one here. They both go into 12 evenly, so that's going to make it a little bit nicer because I only have to multiply the 4 times a 3, and I only have to multiply the 6 times a 2, but I'm going to multiply it by negative 2 just to make it so that I have the correct sign. So on the top one, 4x times 3 is 12x. 6y times 3 is 18y, and then 12 times 3 is 36. That is a 12 right there. There we go. On the bottom row, we're going to get negative 12x when I multiply 6x times negative 2. 9y times negative 2 is negative 18y. And then 12 times negative 2 is negative 24. And now we're ready to add. If I add the column straight down, 12x minus 12x is 0. 18y and negative 18y is also 0. So that whole left-hand side is 0. But on the right-hand side, if I add that down, I get 36 minus 24, which is 12. This is a false statement. That is not true. Those two things do not equal each other. When this happens, if you end up with a false statement at the end, something that absolutely cannot be true, these two lines are parallel. This is the case where there would be no solution. Parallel means no solution, and what we call this mathematically is inconsistent. Okay, when you have solutions, excuse me, it's called consistent. When there's no solution, it is called inconsistent. So again, what you're looking for is once you go through the process, if you end up with some sort of a false statement, then it is inconsistent. There is no solution. It means that the two lines are parallel.